Hello friends. Now after studying fundamentals of engineering mechanics, different terms related to engineering mechanics and how to resolve a force, now in this lecture we will be dealing with resolution of a force along two non-perpendicular directions, that is how to resolve a force along two directions which are non-perpendicular to each other. So let us start with the first problem. I am reading the statement. The 250 Newton force is to be resolved into components along AA dash and BB dash. Okay. Find angle alpha knowing that the component along AA dash is 175 Newton. Also find the corresponding value of component along BB dash. So here figure is given a 250 Newton force. So this is the force 250 Newton force is to be resolved. So we have to resolve this force along two directions. So first direction is AA dash and second one is BB dash. So along these two directions we have to resolve a force. Remember, now these two directions, as we know, components act along two directions of the force. So this is the force and one component will be acting along AA dash, second will be acting along BB dash. So these are the two directions, and if you observe the figure, these two directions are non-perpendicular directions, means this angle is given 40 and hence the angle between these two directions is 140. So these two directions are non-perpendicular to each other, and when the directions along which the force is to be resolved are non-perpendicular, then the resolution is called as skew resolution. So here we have to use the concept of skew resolution. Okay. So in this way, first you should identify the problem. The problem is related to skew resolution. If the directions are perpendicular to each other, then the resolution is called as rectangular resolution, and simply using fx is equal to f cos theta, fy is equal to f sin theta, one can resolve the force. But here the directions are non-perpendicular and hence we have to use concept of skew resolution. Now in this problem, if you read the problem carefully, we have to determine the component of that force, given force along BB dash, as well as we have to determine the angle alpha. So in this problem there are two unknowns, first unknown is angle and the second unknown is force, and we must have two equations with us, and in skew resolution we are using these two equations, equation for F1 and equation for F2. Thus we are having two equations and two unknowns. The problem can be solved easily. Okay. So after identifying the problem, immediately you should write the equations which are related to skew resolution. So first equation related to skew resolution is F1 is equal to f sin of theta 2 upon sin of theta 1 plus theta 2, F2 is equal to f sin of theta 1 upon sin of theta 1 plus theta 2, and according to these equations let us draw a new sketch. So here I am drawing the new sketch. This is force F which is to be resolved 250 Newton. So this force is designated by letter F. Okay, and this is direction AA dash, this is AA dash. So this is AA dash, and I am assuming that let F1 be the force acting along BB dash and F2 be the force acting along AA dash, and hence I am showing F2 acting along AA dash and F1 acting along BB dash. And now I am using these notations F, F1, theta 1, theta 2, etc. And what is theta 1? Theta 1 is angle between F and F1, theta 2 is angle between F and F2. Okay. And our problem is find this theta 2 or alpha, find this theta 2 or alpha. In the given problem letter alpha was used, but now I am using theta 2 because I am using these two equations, and according to these equations I have modified the figure. Okay. So this is theta 2, angle between F and F2, this is theta 1. Now given 40 degree angle is given, So I can calculate sum of theta 1 plus theta 2 using theta 1 plus theta 2 is equal to 180 minus 40. So 140. So theta 1 plus theta 2 is equal to 140. So I am knowing this quantity theta 1 plus theta 2 140. Okay. F2 is given 175 Newton. F is also given, and hence theta 1 is the only unknown. So we can use this equation. So let us use this equation. F2 is equal to F sin of theta 1 upon sin of theta 1 plus theta 2. So F2 is equal to 175 is equal to F 250 sin of theta 1 is unknown, upon sin of theta 1 plus theta 2 140. And solving this equation, you can write sin of theta 1 is equal to 0.4499, and thus theta 1 is equal to sin inverse of 0.4499 is equal to 26.740 degrees, and thus theta 1 is known. And once theta 1 is known, you can calculate theta 2, that is angle alpha in the given problem. Okay, theta 2 in the modified figure. You can calculate theta 2. Theta 2 is equal to 140 minus theta 1, which is equal to 113.25, and thus one unknown is known to us, angle. Okay, and it is asked to calculate corresponding value of component along BB dash. Component along BB dash is F1. So let us use the equation for F1. F1 is equal to F sin of theta 2 upon sin of theta 1 plus theta 2. F1 is equal to F is 250 sin of theta 2. Already we have calculated sin of theta 2 113.25. So 113.25 divided by sin of 140 and is equal to 357.321 Newton. So this is F1, that is component along BB dash, and in this way component along BB dash and angle alpha can be obtained using the concept of skew resolution. So friends, here the important step is identifying the problem. First, you must be in a position to identify the problem, and then you should select appropriate equations. So here first we have identified the problem. The problem is related to resolution of force along two non-perpendicular directions, means skew resolution, and hence we have applied formulae related to skew resolution, and thus we have calculated both the unknowns. So now let us move to the second problem. Second problem is a straightforward problem. Find the magnitude of resolved parts of force F, that is F1 and F2. Now here again we have to calculate resolved parts of F1 and F2. Figure is again given. So this is the figure. First direction F1, first direction say OA, this is the second direction OB, and here the figure is not drawn using protractor. So roughly the angles are shown. Theta 1 is equal to 30 degrees, theta 2 is equal to 75 degree. Remember, theta 1 plus theta 2 is equal to 105, means the angle will be something like this, 105, greater than 90 degree, and this is F2. But this is the rough sketch given, and this sketch gives us an idea that these two components are acting along two non-perpendicular direction, because theta 1 plus theta 2 is equal to 105 degrees, and hence again here we will be using skew resolution. Since in the given figure F1 and F2 are shown, so we need not have to modify the figure. Theta 1 is angle between F and F1, theta 2 is angle between F and F2. So using equation for F1, F1 is equal to F sin of theta 2 upon sin of theta 1 plus theta 2, and F2 is equal to F sin of theta 1 upon sin of theta 1 plus theta 2, and writing all the values of F, theta 2, theta 1, theta etc., we can calculate the components. So first F1 is calculated. F1 is equal to F into sin of theta 2. So F is 500 given, sin of theta 2 75 upon sin of theta 1 plus theta 2. So this is F1, and in the similar way F2 is calculated. So this problem is straightforward. Force is given and its components are required. Theta 1 and theta 2 are also given. So directly you can use the standard formulae and you can calculate the components. Remember, if force is to be resolved along two perpendicular directions, in that case we are using Fx is equal to F cos theta and Fy is equal to F sin theta, but this is skew resolution and that is why we are using these two special equations. So this is the second problem. Resolve a force along two non-perpendicular directions, find F1 and F2. Problem is very simple. Simply we are using the standard formulae to calculate F1 and F2. Remember, the figure is not drawn using scale, but roughly it shows the two components, non-perpendicular components. Now let us move to the third problem. Third problem is resolve the force F1 into components acting along u and v axis and determine the magnitude of the components. So again here we have to determine, we have to find components of F1. So this is force F1, this is force F1, okay, component of force F1 along u and v, along u and v. So first we should check whether u and v are perpendicular directions or non-perpendicular directions. For that we will calculate this angle which was not given, okay. So given 70 degree, 45 degree, this is a straight line. So this angle can be obtained 180 minus into bracket 45 plus 70. So this is equal to 65 degrees. So this angle is known, and after knowing this angle, see this is u axis, we can calculate this angle. So this angle is equal to 180 minus into bracket 30 plus 45 plus 65. So this is equal to 40 degree. So first you should calculate all these angles, and now we can decide whether u and v are perpendicular or non-perpendicular. Now if you calculate angle between u and v, this is 30, this is 40. So this is equal to 70 degrees. So it means that u and v are two non-perpendicular directions, and we have to resolve force F1 along u and v. Means again here we will have to use concept of skew resolution, and accordingly the figure is drawn. Now I am considering only force F1, I am not considering F2. Force F1 is considered, this is direction u and angle between force and u is 30 degree. This is direction v and angle between F1 and v is 40 degrees, and thus the figure is over. Now let us resolve F1 along u and v, and hence let us indicate the component of force F1 along u as Fu, okay, and component along v direction as Fv, okay. So we have to calculate Fu and Fv. Angle between these two is 70 degrees, non-perpendicular, using concept of resolution, skew resolution. So we know the equation F1 is equal to F sin of theta 2 upon sin of theta 1 plus theta 2. So I will consider Fv as F1, Fv as F1, or replace F1 by Fv. So Fv is written is equal to F, force to which is to be resolved, 300 into sin of angle between the second force and component, means theta 2, we are writing theta 2. So if this is considered as F1, this is considered as F2, so this will be theta 2 and this will be theta 1. So 300 into sin of theta 2, 30, upon sin of theta 1 plus theta 2, and thus Fv is equal to 159.62 Newton. Similarly F2 is equal to, using F2 is equal to F sin of theta 1 upon sin of theta 1 plus theta 2, and this is F2. So Fu is considered as F2 is equal to F 300 into sin of theta 1. So now this is theta 1, 40 upon sin of 70. So Fu is equal to 205.21 Newton, and in this way force F1 can be resolved along two non-perpendicular directions into two components Fu and Fv. So while finding these components, first calculate all the required angles. So, here we have calculated these two angles and then we have decided whether the problem is related to skew resolution or not. Okay. So, in this way F1 can be resolved. So, here friends, I will ask you to try resolution of 500 Newton force along U and V. So, you can resolve F2 along U and V. So, it is very easy. First component along U, second along V, this is theta 1, this is theta 2, and using these two equations you can resolve F2 along U and V. Now we will switch over to finding resultant of concurrent force system using method of resolution. As discussed earlier, a force can be resolved along its components, two components x and y. So, here again I am explaining resolution of a force along two perpendicular directions, that is rectangular resolution. So, this is force F, this is angle theta. So, this force can be resolved along x and y directions. So, Fx is equal to F cos theta, Fy is equal to F sin theta. Remember, theta is angle made by the force with x axis of the quadrant in which the force is acting. Now, regarding the directions, F is acting away from the origin, hence Fx and Fy are also acting away from the origin, and since Fx is acting along positive x axis, Fy is acting along positive y axis, both will be considered as positive, having positive sign. Okay. And as explained in the previous lecture, the resultant of concurrent forces can be determined in magnitude and direction using these two equations. First, magnitude r is equal to under root of summation Fx square plus summation Fy square, and direction theta is equal to tan inverse of summation Fy upon summation Fx. So, this you should write in mod, means without considering the sign plus minus sign of Fy and Fx. So, here you should write it in mod. Okay. So, ignore the sign for Fy, summation Fy and Fx. So, in this way resultant of concurrent forces can be obtained in magnitude and direction. Okay. And this is the second concept which we have already discussed. If this is the resultant of the system, this is angle theta, then the x component of resultant is summation Fx is equal to r cos theta, y component of resultant is equal to summation Fy is equal to r sin theta, which is similar to resolution of a force. So, here simply a resultant is resolved, and if you resolve resultant along x and y direction, the x component we will indicate with summation Fx and y component with summation Fy. Okay. Now, let us start the problems. First problem is determine the resultant of the force system shown in figure. Now, the problem is related to finding resultant of force system. We know that when two forces are acting at a point and their resultant is to be determined, we can use law of parallelogram of forces to calculate their resultant, But if number of forces are acting at a point, then law of parallelogram cannot be used, since it is applicable for two forces only. Now, in this problem three forces are acting, so law of parallelogram cannot be used. Instead of that, here we have to use general method, that is method of resolution, to find the resultant of the given force system. Now, this is the problem, figure is given, determine the resultant of the force system. So, identify the problem. Problem is related to finding resultant of force system, resultant of three forces. If two forces are there, we can use law of parallelogram, but here three forces are acting, so we have to use method of resolution. And what is method of resolution? First step is find summation Fx, that is algebraic sum of x components of all the forces. So, let us calculate summation Fx. Now, first step is summation Fx is equal to, now we have to resolve all these forces along x axis in their x component. So, starting with 80 Newton force, x component of this force, we know Fx is equal to F cos of theta. So, here F cos of theta, 80 cos of 40, 40 is the angle made by 80 Newton force with x axis. So, force is acting in the first quadrant, force is acting away from this point, components will also act away from the point. So, x is acting to the right, positive sign, positive x axis. Okay. Now, the second force plus sign, because again 120 Newton force is acting in the first quadrant away from the point. If you resolve this force along x and y direction, so let us talk about x only. If you resolve this force along x component, component will act along x axis away from the origin. So, component is acting along positive x direction. So, plus 120 into cosine of angle made by that force with x axis. So, 120 is magnitude 120 cos of 70, because angle made by 120 Newton force with x axis is 40 plus 30, 70. So, 120 plus cos of 70. Now, the third force, x component of the force is f cos theta, 150 cos of 35. Now, force is acting in second quadrant. So, this is pull type force in the second quadrant, x negative, y positive. So, you can use negative sign for x component. Okay. Or force is acting away from the point, component x is acting away from the point to the left or along negative x axis, hence put negative sign for x component, minus 150 cos of 35, and thus summation fx is equal to minus 20.546 Newton. This is summation fx. Similarly, determine summation fy. Now, summation fy is sum of y components, and we know how to resolve a force along y direction. So, force F angle theta, fy is f sin theta. So, here we will resolve all these forces along y direction starting from 80 sin of 40, 80 sin of 40, y component acting away from the point, positive y direction, plus 80 sin of 40, plus second component. Now, 120 Newton force, if you resolve along y direction, component will act away from origin along positive y direction, plus 120 sin of angle made by the force with x axis, 40 plus 30, 70, 120 plus sin of 70. Y component of third force, 150 sin of 35 away from the point along positive y direction. Okay. So, plus 150 sin of 35. So, summation fy is equal to 250.22 Newton. So, in this way the forces are resolved along x and y directions, and summation fx and fy are obtained. Now, the third important step is finding magnitude of resultant. Magnitude of resultant can be obtained using equation r is equal to under root of summation fx square plus summation fy square. So, here let us write down the equation r is equal to summation fx square plus summation fy square. Now, summation fx is known to us, minus 20.546 square plus summation fy square 250.22 square. So, solving this equation, you will be having magnitude of resultant 251.042 Newton. So, this is the magnitude of resultant r of all the three forces. Now, since resultant is a vector quantity, we have to determine its direction. So, direction theta is equal to tan inverse of summation fy upon fx. So, is equal to tan inverse of summation fy 250.22 upon summation fx 20.546. Remember, here I am ignoring the sign of summation fx. Okay. So, you have to ignore the sign, that is why I ask you to write it in mod. Okay. So, tan inverse of this quantity is 85.30 degrees. It means that this is the direction or this is the angle made by the resultant. Now, we have to decide in which quadrant the resultant is acting. So, you can refer the previous lectures. I have already explained how to decide the quadrant for resultant. Now, here summation fx is negative, summation fy is positive, and we know in the second quadrant x negative, y positive, and that is why this resultant is acting in the second quadrant. So, in this way resultant of number of forces can be determined in magnitude and direction completely. Okay. So, finding resultant means, suppose these are the three given forces and this is resultant. It means that we can replace all these three forces by a single force, and that single force is resultant, 251.042 Newton. Okay, this is the meaning of resultant. It is a single force which can replace all the given forces. Now, when you replace these given forces by a single force to produce the same effect, you have to apply this force 251.042 Newton at point O, making an angle of 85.30 degrees with x axis of the second quadrant. So, force will act like this. This is the second quadrant and resultant is acting in the second quadrant. So, in this way resultant can be determined completely. Now, let us discuss the third problem. Again, determine the resultant of three forces shown in figure. Now, forces are acting on a hook and these forces are shown in figure. So, first force is of 60 Newton acting in the first quadrant, making an angle of 25 degrees with x axis. Second force is of 40 Newton making an angle of 60 degrees with the x axis. Third force is acting in the third quadrant, 50 Newton force making an angle of 50 degrees with y axis. So, here angle made by this force is given with y axis. Okay. So, let us solve the problem. Problem is related to finding resultant of number of forces. So, we can use, rather we have to use method of resolution. So, using method of resolution, the first step is summation fx, find summation fx. Now, let us resolve each force along x direction. So, starting with first force, F cos of theta, 60 cos of 25, first quadrant pull type force, x will be positive, 60 cos of 25. Okay. Now, the second force is acting in the fourth quadrant, x component of this force 40 cos of 60, 40 cos of 60 along positive x axis, hence plus 40 cos of 60. Now, x component of the third force 50 cos of theta. Now, theta is angle made by the force with x axis of that quadrant. Force is acting in the third quadrant. So, we have to determine angle made by the force with x axis of third quadrant, and this angle is equal to 40. So, 50 cos of 40 negative x axis minus 50 cos of 40, and hence summation fx is equal to 36.076 Newton. So, summation fx is known. Now, summation fy, let us resolve each force along y direction. So, first force 60 sine of 25, first quadrant acting along positive y axis, plus 60 sine of 25 minus 40 sine of 60. Why minus sign? In the fourth quadrant negative y direction is there. Okay, minus 40 sine of 60. Then y component of the third force is acting in the third quadrant. So, this is the force 50 acting away from the origin, y component will also act away from the origin along negative y direction, hence minus 50 sine of 40. Remember, while finding the components you have to consider angle made by the force with x axis, not with the y axis. So, this is 40. So, minus 50 sine of 40, and hence summation fy is equal to minus 41.42 Newton. So, summation fx and fy are known to us. Now, let us determine the magnitude of resultant. Magnitude r is equal to under root of summation fx square plus summation fy square. Summation fx is known to us, summation fy is known to us. Solving this equation, it gives us magnitude of resultant 54.93 Newton. Okay. And the direction of resultant, since resultant is a vector quantity, we have to determine its direction as well. Direction theta is equal to tan inverse of summation fy upon summation fx. Now, here we are not considering the plus minus sign for fx and fy. So, tan inverse of summation fy, only magnitude I am considering 41.42 upon 36.076, and thus theta is equal to 48.94, and this is the direction of resultant. Since summation fx positive, summation fy negative, it means that resultant lies in the fourth quadrant. So, resultant is acting in the fourth quadrant. This is the resultant making an angle of 48.94 degrees with x axis of the fourth quadrant, and thus the resultant can be determined completely. So, here you should note this point: angle made by this force with y axis is given. So, while performing the calculations, we are considering angle made by the force with x axis. This is very important. Normally students are considering this angle, and if you use this angle to write x component 50 cos of 50, your answer will not match with the correct answer. Okay. And now the third problem. Two control rods are attached at A. I have already solved this problem in the previous lecture using law of parallelogram of forces, but here we will not use law of parallelogram, but we will use concept of resolution. Two control rods are attached at A. So, this is control rod and this is point E. Okay. Control rods, these are the control rods at A to lever AB. This is lever AB. This is lever AB. On this lever forces are acting. Knowing that force in the left rod is F1. So, this is the force in the left rod is F1, 120 Newton. Determine the required force F2 in the right hand rod if the resultant of the forces exerted by the rods on the lever is to be vertical. So, figure is given. This is F1 120 Newton, this is F2 which is not given, which we have to determine angle made by each force with x axis given, and the condition is given. Here when such condition is given in the problem, it means that you have to use that condition to solve the problem. So, here determine the required force F2. We have to calculate this force F2 if resultant is vertical. If resultant is vertical. Now, we have already discussed it during resolution. If R is vertical, find F2 if R is to be vertical. So, as we know, when resultant is to be vertical, resultant is to be vertical, sum of x component, that is summation fx, will be equal to 0 and summation fy will be equal to resultant R. So, this is important condition one must know. Again, let us come to this figure. This is resultant R, this is direction of resultant, and hence summation fx is equal to R cos theta, summation fy is equal to R sin theta. But if resultant is acting in vertical direction, its x component will be equal to 0, means summation fx will be equal to 0 and summation fy will be equal to R sin of 90, because resultant is acting along y direction. So, summation fy will be equal to R and summation fx will be equal to 0. So, in this problem we have to use that condition. When resultant is vertical, summation fx is equal to 0 and summation fy is equal to R. Now, we are having two unknowns, F2 and resultant R, and we are having two equations, summation fx is equal to 0, summation fy is equal to R. So, you should start with a equation whose right hand side is known. So, here right hand side of this equation is known 0, while right hand side of this equation is unknown. So, let us start with summation fx is equal to 0. So, for the given system, this is the given system, let us calculate summation fx and equate it with 0. So, calculate summation fx. So, first force F2, resolve it along x direction, F2 into cos of 10, positive x direction, plus F2 cos of 10. Then the second force is acting, this force is acting in the second quadrant, this is y direction, this is x direction. Second quadrant, force is acting away from point A, component will also act away from point A along negative x direction. So, 120 cos of 28 with negative sign minus F1 cos of 28 is equal to 0 according to the given condition. So, our equation is F2 cos of 10 minus F1 cos of 28 is equal to 0. F2 is equal to, which is unknown, F2 is equal to F1 cos of 28, F1 is known, 120 cos of 28 upon cos of 10, and thus F2 is equal to 107.58 Newton. So, in this way F2 can be obtained using given condition is R to be vertical. So, I have used this condition. If you refer our previous lecture, we solved this problem using law of parallelogram of forces, but this method is very easy comparatively if you compare it with law of parallelogram of forces. Okay. So, summation Fx is equal to 0, it gives us F2 107.58 Newton. Now, let us use the second equation, summation Fy is equal to R. Now, let us resolve the forces along y direction, calculate summation Fy. Y component of F2, F2 sin of 10, F2 sin of 10, first quadrant y will be positive, plus F1 sin of 28, again second quadrant y will be positive. Okay. So, F2 sin of 10 plus F1 sin of 28 is equal to R. Now, magnitude of F1 and F2 both are known to us. Therefore, R is equal to 107.58 into sin of 10 plus 120 sin of 28, and hence resultant is equal to 75.19 Newton. Here we need not have to determine the direction of resultant because it is already given. Resultant is acting in vertical direction. So, in this way resultant of the forces can be obtained. Actually, in this problem two forces are acting and their resultant is required. So, one can use law of parallelogram of forces as explained earlier, and here we have used method of resolution, particularly the condition when resultant is vertical, summation Fx is equal to 0 and summation Fy is equal to R. So, this is all about finding components of a force along two non-perpendicular directions and finding resultant of a force system using method of resolution. So, this is all about skew resolution and finding a resultant of concurrent forces using method of resolution. In the next lecture, we will be discussing about finding resultant of non-concurrent forces. Thank you.